I am Anil Kumar, sharing with you a lesson on logarithmic and exponential functions with my student Chelsy. We'll discuss solution to some equations and word problems which are part of assignment for students doing advanced functions here in Toronto, Canada. I hope you will learn from this and get ready for higher courses like calculus.
Hi, Chelsy. How are you doing?
Hi, sir. I'm good. How are you?
Very good. Very good. So now these days, what are you working on?
So I'm still working on logarithms with my class, and I have some practice examples from my teacher that I wanted to go with.
Oh, we can discuss them. Why don't you share? I'll help you understand those things. Okay. So let me just give you sharing. Yeah, you can share. MHF4U 8.1, 8.2 quiz question number 1. Let's see. What is question number 1 for you?
So here it's write in exponential form log base 5 to 8 minus 2 equals 3m.
How will you do it? Tell me.
So it's asking to write it in exponential form. So would it be a minus 2 equals 5 to 3m?
You're right.
Okay.
So the concept is that 5 is the base, right? So in this case, 5 is the base. This is very important, correct? So maintain that. So base is 5. So for the exponent, this is your base. Is that okay?
Yeah.
Perfect. Question number 2.
Write in logarithmic form r equals s to the power of negative t minus 1.
Okay. Now in this case, you have to maintain the base. What is the base here? S is the base, right?
Yeah.
So you take log to the base s on both these sides. Let me show you this process because sometimes it is a confusion. So I'm writing this equation first. R equals to s to the power of minus t minus 1. So I'm taking log both sides, log, but with the base s. You understand? Base is s. And both sides. So log to the base s of s to the power of minus t minus 1. This step is clear to you?
Oh, okay, yeah.
Now, the left side is log to the base s of r. So we have got the logarithmic form here, right? On the right-hand side, what is log to the base s of s to the power of minus t minus 1? Is only minus t minus 1. Do you see that?
Yeah.
So we get the logarithmic equation, which is log to the base r. Let me rewrite. Log to the base s of r equals to minus t minus 1. Done.
Okay, good.
So you can check. S to the power of minus t minus r is r. We get the same equation. So it is like interchangeable. You have to only take care that the base remains same. Then it is perfectly fine. Is that clear to you?
Yeah.
Perfect. Question number 3 now.
Number 3 has two parts. For the parent function, y equals log to the base 3 to the x. Part A, write the equation of the graph after a vertical flip, vertical stretch by 2, horizontal compression by 1 over 3, and a move to the left by 1.
Okay, so let's do this. So let me use another ring. So first part is that there is a vertical flip. So vertical flip means what?
So negative a value.
Negative a, right? So it becomes y equals to negative log to the base 3 of x. This takes care of vertical flip. Next step is vertical stretch by 2. That means it should be negative 2 log to the base 3 of x. That takes care of vertical stretch by 2 following the flip. Horizontal compression by 1 over 3 will mean, I should not say y equals 2. We are just going step by step, right? So first, second, and third, we are doing vertical, horizontal compression by 1 over 3. So we already have minus 2 log to the base 3 of, when it is horizontal compression, it will flip 3x. You see that?
3x. Yeah.
and then moves to the left by 1 unit. Left means horizontal, right? So it means minus 2 log to the base 3 of
Plus
3 outside x plus 1, correct?
yeah.
So those are the required transformations which will give you the equation. So let me write down the final equation now, and let the final equation be written here. So we have y equals to, so we have minus 2 log to the base 3 of 3 times x plus 1. Is that clear to you?
Mm-hmm.
So that
Yeah.
becomes our answer. You have understood all these steps, right?
Yeah, and the 3 should always be on the outside, right?
Factor it out. So factor 3. Very good. Correct. So we've done this, right? And
Mm-hmm.
now part B is sketch.
Sketch the parent function and transition graph and a transformed function.
Okay. So to sketch the transition graph, so they have put S there. Let me clear the screen now. Can you put this? We'll just focus on this last question. Yeah.
Yeah.
Let me write down the equation also. So go a bit. Okay. I think it's okay. It's okay. Yeah, this much is good. So let me write down the equation. We got the equation as y equals to minus 2 log to the base 3 of it was 3 times, right? 3 times
Yeah, 3x minus 1
plus 1.
or plus 1 plus 1.
Yes, this is your equation. Now, what we could do, if you have assignment type of equation, in that case, what you could do is you can make a table, right?
Yeah.
With the coordinate points. So base function is log 3x. The important coordinate points are that it is a vertical asymptote at x equals to 0, right? So let me write down these points here. So first thing is we'll say vertical asymptote at x equals to 0. Is that clear to you?
Yeah.
Now we'll look into the points. Since the base is 3, that really means that if x is, let us say, if what is log 3 of 3? Log 3 of 3 is 1, right?
Mm-hmm.
So if I write 3 here, I will get 1 value. Is it okay?
Yeah.
If I write 3 to the power of minus 1, that is 1 over 3, correct?
Yeah.
Then the value will be, sorry, I should have written minus 1. That is a y value I wrote. So if I write x as 3 to the power of minus 1, 3 to the power of minus x as 3 to the power of minus 1, that is 1 over 3. Then the y value will be minus 1, correct? If I write 3 square, which is 9, in that case, I'll get 2 as y value, correct?
Yeah.
And if I write, when is log of, what is 0? What is the x-intercept?
It's always 1.
1.
Yeah.
Add 1, right? So I missed
So
in that 1. So I'll write 1, 0. Is it okay? So I have to space it out. So you can space this out. Is it okay?
Yeah.
Perfect. So these are your critical points. Now, you could always sketch this, but first thing is we'll make this, right? So we are saying that we have log of, first we have a vertical flip, and let's look into the vertical reflection. Is it okay? So I'm saying minus 2 log 3x. Is it okay? You can write down the values. Then we can take minus 2 log, I'll erase this later. Let me clear this. Can you reduce the screen so that I get more space to make this big table? Yeah, that's good. That's good. Yeah, reduce more. Then we will have table reduce. Yeah, other way, more. Very good. Very good. So we have to sketch the function y equals to minus 2 log to the base 3 of, here it was 2, right? 1/3, 3 times.
3 x plus 1.
Plus 1. So ultimately, if I have a point x, y on the original graph, then this function will have an image at coordinate point, which x value will be 1/3, correct? And then -1 because it moves left. And the y value will get multiplied by 2. Is that clear to you?
Yes.
So from initial to final, that is our final result, right? Now, when we are looking into the initial value, first thing is that the vertical asymptote we are looking at is what? Vertical asymptote is always for the original function at x equals to 0. Is it okay?
Yeah. And then for the final function, because it's moving left, would it be -1?
Yes.
Okay.
Now, for every logarithmic function, if I have the x-intercept, it will be only at 1, right? So if x equals to 1, in that case, y is equal to 0, right?
Yeah.
So that means when you plug in the image points, x value becomes 1/3 minus 1. So 1/3, 1/3 minus 1 is minus 2/3, right? And the y value is 0. Correct? If I plug in the value as 3, then log 3 of 3 will be 1, right? Transform it. So 3 times 1/3 is 1, and 1 minus 1 is 0. So use your calculations, and this is -2. Is that correct calculation?
Yeah.
Very good. And if I substitute x as 1/3, then it will be -1. So here I'll get 1/3 times 1/3 is 1/9, and 1/9 minus 1 means 1 minus 9, which is -8/9. Y value -1 times -2 makes it +2. Is that clear to you?
Yeah.
So these points are good enough to sketch your graph, right? So broadly speaking, the graphs will be looking like what? Let us say this is our function where I'm drawing the graph of log 3x first. Let's say this is log to the base 3 of x. Is that clear to you? Now our function will be reflected and then move left by 3 units, right? So move by 1 unit, right? So we have a vertical asymptote at this point. This is a vertical asymptote, right?
Yeah.
X equals to -1. And when you plug in these points, you clearly observe that, see, it is vertically lifted. So the x-intercept is at -2/3, right? So it is somewhere here, right? So what you get here is a graph which is kind of like this. Is that okay?
Yeah.
Where you can label your points as shown here. Is that okay? So -8/9 is very close. So that is, let's say, 2 here. I'm just writing some values, right? So that is 2 at -8/9, right? And 0 at -2/3, right? And then at 0, we have -2. Is it okay?
Yeah.
So we get a final graph, which is the y value, right? But, so that is your final, right? But can you please read the question once again?
Sketch the parent function, transition graph, and transform function.
Transition graph is the key word. Do you get the idea?
Yeah.
So transition graph really means that will be your final. In between graph also you have to sketch. You get the idea? So in between graph, let me just show you a couple of them, but you should do it on your own later, right? So, for example, the very first one is a vertical stretch and reflection by -2. So the point invariant will remain here only. Y as vertical asymptote will remain same, correct? And we are reflecting, and let's say these are your two critical points, let's say, right? Then they get vertically stretched and reflected. So this becomes twice, and this also becomes twice. So what you get here is a graph which is kind of like this, right? So this is the graph which I'm sketching of -2 log to the base 3x. So we have taken care of the vertical. Do you see that?
Yeah.
So we have taken care of vertical stretch and reflection, right?
Mhm.
And after that, we will do the horizontal compression and translation. Do you see that? Correct? So you need to make a table here. So first is, of course, log to the base 3 of x, which gives you all those points, which I'm saying x, y. And then you should have here -2 log to the base 3x coordinate points. Apply the transformations, which will be x value remaining same, y value becomes 2y. Is it okay?
Mhm.
And then you have -2 log to the base 3 of horizontal stretch, which is by a factor of 1/3. So 3x. Is it okay?
Yeah.
So make this, which is from here, we know that x now becomes 1/3 of x and the y value is -2y itself. Is it okay? From the original we are saying. And then the last one, which is our final one. Is it okay?
Mhm.
Which I am saying y. Is it okay? Just y. Which is this y, where the transition will be that, which we have sketched in green. Is it okay?
Yeah.
So these are the steps required. 1/3x minus 1 minus 2y. Perfect. So that will complete the whole thing. Is this concept clear to you?
Mhm.
So, okay, let's move on. Let's clear this. Perfect. Yes. Can you summarize what did we do here?
Yeah, so we did a question where we had to find the log form given exponential and then find the um, exponential form given the log form.
Right.
And then we did transformations and graphing and then also finding the equation when given transformation.
Perfect. Very good. Any other question?
Uh, yes, I have some practice problems also for my teacher.
Let's look into that.
I shared my screen. Can you see it, sir?
Yeah, I can. Yeah. So exponential equations, a radioactive substance in a container initially contains 500 grams. After 18 days, there are 400 grams remaining. What is the half-life of the substance? So I'll write down the formula for half-life. So, the amount at any time will be initial amount, and we're looking into half-life. So half of time over half-life period written by age. Is that okay?
Yeah.
So it says radioactive substance is in a container contains 500 grams. So A0 is 500 grams. After 18 days, so T is 18, right? So half T is 18 divided by, we don't know what H is, we get 400 grams. You see that?
Mhm.
So that is the equation to be solved. Perfect. So from the half-life equation, we have got 400 equals to 500 times half to the power of 18 over h. So you can divide 400 by 500 and you get half to the power of 18 over h. So that is 4 over 5. So we have 4 over 5. Now we are going to take log on both these sides, right? Log to the base 10. And here you take log of half to the power of 18 over h. So applying the rules, the right hand side will be what? 18 over h. Log of half, correct?
Yeah.
And now we can isolate half-life, cross multiply. So h goes on this side. So we get h equals to, we have 18 log of half divided by log of 4 over 5. You can use calculator and calculate this value to get the half-life. Clear?
Yeah.
So once you write this, you have to isolate h. That is the process. Isolate h. Right. And we get h equals to 18 log of half over log of 4 over 5. What do you get?
The final answer, H, I got 56.25.
Okay. Okay, what is the half-life of the substance? So more than 56 days, right? So 56 and quarter days. That is what you get. Correct. Should I check the calculation?
Mm-hmm.
Okay. So we have 18 times log of 0.5, and then we'll divide by log of 4 divided by 5. 55.9 I get. So I get 56 days. Very close.
I think, no, sorry, I got the H value as 56.25.
56 days. Okay, that's fine. So we get H as 56 days here. Okay.
Yeah.
So that's our answer. And I hope the standard method is clear. Is it clear?
Mm-hmm.
Let's move on to the next question. Anyway, you can do the calculations. Approximately 56 days.
Yeah. Okay. Example B.
Can you please read the question?
Yes, an investment of 2,500 grows at a rate of 4.8% per annum, compounded daily. How long will it take for the investment to be worth $6,000?
Compounded daily. How long will it take for the investment to be worth 6,000? So we want the final investment to be 6,000. Is it okay?
Yeah.
Correct. So since it is compounded daily, it really means that there are 365 days, right? And 4.8%. So rate of interest will be 4.8% means out of 100, correct?
Mm-hmm.
Times 1 over 365. Because every day you are getting interest. Is that okay? And how long will it take for the investment to be worth this much? That time will be in years, but in a year, it is going to get multiplied by 365 times at this rate, right?
Yeah.
Therefore, the formula will be the amount at any time will be initial amount times 1 plus the rate of interest, which in our case is 4.8 over 100 times 1 over 365. You can calculate this. And the power will be number of times it is getting compounded. So if t is in years, then it will be 365 t. You get the idea? Every day it gets compounded. So t is what we have to find. We know everything else. So we can now substitute the final value of 6,000 here equals to 2,500, which is the investment, 1 plus, can you please calculate this? 4.8 over 100 divided by 365, or just keep it like this. You can add 1 to this. Yeah. So just keep it like this. That will be better. Okay. It'll be good for you to. So let's say this amount is, what do you get? So let me do 4.8 divided by 36,500. Okay. And this is 6 over 45625. Is it okay?
Okay.
So that is what you get. Is it okay? Now, you have to find t just as we did in the previous question. Exactly same method. So first you divide, right? So when you divide, what you get? There's less space here. So I'll do it on the side. So we have 600, 6,000 over. You can divide this, right? Okay, let me write one step here itself. So we have 6,000 divided by 2,500. Get this number. Equals to 1 plus 6 over 45625 to the power of 365t. Is it okay? It is 365t, not slash. Because those many times. Right. Now, so what is there on the left side? Can you do 6,000 over 2,500? What do you get?
2.4.
Right, 2.4. So we can take log on both the sides, correct? So we get log of, so we have log of 2.4 equals to log of, we get this 365t log of 1 plus 6 over 45625. Okay. Now you can isolate t, and therefore we get t as equal to 1 over 365 times log of 2.4 divided by log of 1 plus 6 over 45625. Is that clear to you?
Yeah.
So that is the time period in which this money is going to grow almost 2.4 times $6,000. Is that clear to you? You can do this calculation later. We can move on to the next question. Okay?
Okay.
Fine. Let's check the next question.
Okay. These questions.
Okay, let's do them one by one. Can you help me doing the first one? 2 to the power of x plus 2 minus 2 to the power of x is 24. This is actually a quadratic equation. Let me show you how. So this first term is 2 to the power of x. When you say plus 2 means times 2 to the power of 2. Is it okay?
Yeah.
Minus 2 to the power of x equals to 24. Is that clear? So we can take 2 to the power of x common, right? 2 to the power of x is common, and we get 2 to the power of 2 minus 1, which is 4. 4 minus 1 is 3. Is it okay? So 2 to the power of x times 4 minus 1, which is 3, is 24. 2 to the power of x is 24 over 3, which is 8. 2 to the power of x is 2 to the power of 3, since 8 is 2 to the power of 3, and therefore x is equal to 3. Is that clear to you?
Yeah.
The second one. 3 to the power of 2x, 5 times 3 to the power of x is minus 6. So here we will do a substitution. So what I'm going to substitute is that 3 to the power of x, let it be equal to, let's say, p. Then what is 3 to the power of 2x? P square, right? Is that clear to you?
Yeah.
So I will replace 3 to the power of 2x as p square minus 5p equals to minus 6. Bring them together. P square minus 5p plus 6 equals to 0. You can factor. 3 times 2 is 6. Minus 3 minus 2 will give you minus 5. So p minus 3 minus 3 times p minus 2 equals to 0. So p is equal to 3 or p is equals to 2. That becomes your answer. But you have to find x. So what we get here is 3 to the power of x equals to 3. That gives you x as equal to 1, correct? 1 value. The other one is 3 to the power of x equals to 2. To find the value of x, you have to take log this time, correct?
Yeah.
So that means 3 log x equals to log 2. So, oh, right, sorry, cube root. Sorry, let me read. Sorry. Okay. X cube is 2. So x is cube root of 2, right?
Yeah.
So those are the two answers. So x equals to 1 and x equals to cube root of 2. So that is how we are going to solve this particular question.
Okay.
Clear. Next question, please.
This one.
Very good. 9 to the power of x. So 9 and 3, we have different bases. Do you see that?
Yeah.
How can you make the base same? Tell me.
Well, 9 is the same as 3 to the power of 2.
Perfect. So very similar to the previous example. Again, what am I going to do it? This is 3 to the power of 2x minus 5, 3 to the power of x, bringing 6 here, plus 6 equals to 0, correct?
Yeah.
So this time it is plus 6 instead of last time's, correct? So you could substitute p, right?
Yeah.
We'll do that. So we'll again write the substitution. Let p equals to 3 to the power of x. So p square equals to 3 to the power of 2x. And that gives us the substitution here. We get p square minus p plus 6 equals to 5p, sorry. And since we need product as plus 6, again, what we are going to do, same thing, right? So we have p minus 3 times p minus 2. Is it okay?
Yeah.
And same answer as before, correct? Is it okay? So p equals to 3, p equals to 2, right? So p is 3 to the power of x equals to 3. That means x equals to 1. 3 to the power of x equals to 2. Oh, sorry. It was 3 to the power of x equals to 2. I should have taken log. I did a mistake there, right? I wrote x to the power of 3. Sorry. 3 to the power of x equals to 2. So we'll take log. So x log 3 equals to log 2. And x is equals to log 2 over log 3, correct?
Yeah.
So we have our answer. You should correct the previous one also. X is equals to log 2 over log 3. Is it okay? And also we get x equals to 1. Okay.
Okay. That was the last one for here. I also have these questions.
Okay, we can quickly go through that. So can you help me doing the first one? I'll do on the side. Log to the base x of 0.04 is minus 2. What will you do here?
Do you move the 2 to the other side?
Yes, so we can write 0.04 equals to x to the power of minus 2, right? Which is 1 over x squared. Is that okay? So therefore, x squared is equal to 1 over 0.04. X is equal to square root of 1 over 0.04. Can you figure out how much it is? And we know x value is positive, and therefore it has to be only positive answer. Correct. Tell me what you get.
25.
Yeah, because this is like square root of, you have to do 100, right? 100 over 4 is 25, which is 5, correct?
Mhm.
So you get 5 as your answer, correct?
Yeah.
Next question. Log to the base 7 of 3x minus 5 is log to the base 7 of 16. So basically, in that one, just equate these two. So we get 3x minus 5 equals to 16. And we have 3x equals to 16 plus 5, which is how much? 21, right? And then divide 21 by 3, and you get 7 as your answer. Is that clear?
Yeah, so in this question, what we're doing is we're equating the exponents as long as the base is the same.
Correct.
Okay. But like for this question, the first one that we did, the
Yeah.
base is not the same.
So we turned it into exponential form.
Mm-hmm.
So we wrote x to the power of minus 2, which is 1 over x squared, equals to 0.04 as shown here, right? And then x will be square root of that number, and we calculated square root, and we know x is greater than 0, and therefore we have taken only the positive value, correct?
Yeah.
That's what we did.
I can.
Log properties. So when you have log something minus log something with the same base, it means what? You're dividing, right?
Yeah.
So the left side here is log to the base 2 of 30x divided by 5, which is equals to log to the base 2 of 12, correct? So you can again equate 30x divided by 5 is 6x. So 6x is equals to 12. X is equals to 12 over 6, which is 2.
Yeah. Okay.
Next one. Log x plus log x squared equals to 12 means multiply them, right? So it is, let me write down.
X times x squared, so x cubed.
Yes. Log x cubed equals to 12. So that means x cubed is equals to 10 to the power of 12, correct?
Mm-hmm.
Now, so 10 to the power of 12 is 4 times 3, right? So we could write x cubed equals to 10 to the power of 4 to the power of 3. Do you see that?
Yeah.
So x is equals to 10 to the power of 4.
Oh, okay.
That's how you do.
Yeah, my teacher did. She moved 3 in front of, so she did 3 log x equals 12.
Yes, you could do like that. 3 log x equals to 12, then also you'll get. So let me do that. Alternate, right? So after this, actually after this, we could say 3 log x equals to 12. Log x equals to 12 over 3, which is 4, correct? So
Yeah.
x is equals to 10 to the power of 4. That is correct. Same answer, correct? Next
And
question, please. Yeah.
it's 10 because the
Base is 10.
default is base 10. Yeah. Okay. Here's the last one.
Last one, just multiply. So we have log to the base 2 of x plus 3 times x minus 3, which is equal to 4, correct? So that means x plus 3 times x minus 3 is x squared minus 9, right? Equals to 2 to the power of 4, right? Which is, 16, correct? So we have an equation now, which is x squared equals to 16 plus 9, which is 25. So x is equal to square root of 25, which is 5. And here, x is greater than, let me write down the condition, right? X is greater than minus 3, and this fellow is x is greater than 3, right? Do you see this?
Yeah.
So that is our restriction. So we cannot take minus 5. That would be an extraneous root, right? So we have x equals to 5 as our only solution. Clear?
Yeah. So because when you do square root, it could be plus minus 5.
Yes, yes.
We use the restriction in the question to figure out which.
Yes, that is correct. So we're done with all this?
Yeah.
Now
So,
what next?
Can we do some application problems, sir?
Sure, we'll do application questions, and I think we'll move on to my playlist. Is it okay? So let me just share with you my playlist. YouTube, where are you? I think this one. Okay, so do you see this playlist which is on logarithmic word problems, correct?
Yeah.
So we have 16 questions in this. Basically, what I see over a period of time, that there are only 4 or 5 applications where logarithmic functions are used extensively, right? And in the test, one of them will be there, correct? Now, for example, one of the videos is just going on, which is about doubling time. We did half time, correct? This is double population time. Can you please read the question?
Yeah. Sorry, sir.
Yeah.
A population starts at 1,000 people and has a growth rate of 4%. In how many years will there be 2,000 people?
Correct. Simple as that. So standard formula 1 plus RT, right, to the power of t. It's like compounding. And we have put the initial 1,000 and final is 2,000. And we have given the growth rate, which is 4%. That means 4 over 100. We need to find the value of t. So basically, we will just take log both sides and solve for t. Correct? That is how you're going to do it. Perfect?
Yeah. So I noticed in these questions, and even in the one we did earlier, there's always the 1 plus in the equation. Why is that there?
1 plus rate. You understand? If it is anything times 1, you get the same amount as you deposit. Let's say you 1,000 times 1 will be 1,000 only. But if I have a 10% increase, then I'm getting 1.1 times 1,000, right? 1,100 I will get after a year. You get the idea.
Yeah.
That
So
is
if
the growth rate.
any rate type questions, there's usually 1 plus.
1 plus R, yes.
Yeah, okay.
So let's look into the next question, which is what here? Can you please read this question?
Yes. Bones from a human body were found to contain only 76% of the carbon 14 in living bones. How long before did the person die? The half-life of carbon 14 is 5,668 years.
Very important question. So you can find the time, right, with this just by checking the density in the bone, right? So you can apply the formula which you have recently learned, which is half-life formula, correct? So whenever it is like half-life, then what are we doing? So half-life formula is final amount. Final amount A will be equals to starting amount. And when it is half-life, we put half in the bracket. Growth rate is half, decaying, right? So something is decaying. And time period over half-life time period. That's the formula, which you apply and get your answer. Get the idea. Just as we did the half-life question in your assignment or your shared questions. Is it okay? So we can always, okay, now let me just, I'll have to stop annotating. Okay, I'll again go back and share with you. Wait. Perfect. Let me take more examples. Here is another example randomly picked up. Can you please read the question?
Yes, the pH of a fruit juice is 3.20. What is the hydrogen ion concentration of the fruit juice?
So we'll read decimal places 3.20, right? Not 20. So the pH of a fruit juice is 3.20. What is the hydrogen ion concentration of the fruit juice? So straight, this is a log formula. And as you can see in the solution, I've just moved my video on the extreme to just show you the formula, 1 minute video with such a good information right there. So pH is minus log of hydrogen concentration. So you can write down this formula. And here we are given that the pH of the fruit juice is 3.2. So we are given the left hand side as 3.2. And we need to find the hydrogen ion concentration written by H plus, right? So it is 3.20 is minus log of hydrogen ion concentration. So taking care of the sign first, log of hydrogen ion concentration is minus 3.20, and we are writing it in the exponential form. So hydrogen ion concentration will be 10 to the power of minus 3.20, correct?
Yeah.
You can use the calculator to calculate the value. So you can solve pH questions. There are many such pH questions here. You can see, for example, the next one here, right? So you can do a lot of pH questions from this playlist, couple of them. Now, some variations, sometimes we give you the concentration and to find the pH, as in this case, we are giving you the concentration now to find the pH. So basically, you have to rearrange the formula just as we did last time. Same formula, pH equals to minus log hydrogen ion concentration. And since we are given hydrogen ion concentration, we will find the pH. Now it is 5.9 times 10 to the power of minus 8. You can use the logarithmic rules also as shown here. Do you see that rule? So these are very short videos, just 1 minute, 2 minute videos, right?
Yeah.
Even it takes longer for us to explain. Then the whole solution is there on the screen, right? So, as I was saying, you just write down the formula and then, calculate log of 5.9 using your calculator, and 10 to the power of minus 8 is minus 8, right? So
Yeah.
you don't even have to use calculator. Just write minus 8 and get your answer. This is what I wanted to show you, correct? Now let me take some more examples. We'll talk about intensity of earthquake. That is a very common and a popular question in any test on graph paper, on logarithms and exponential functions, right? So have a look at this particular question. Can you please read it?
Yeah. What is the magnitude of the earthquake 3 times intense as 5.0 on the Richter scale?
So you're basically comparing the two, right? Ratios. So the formula for the earthquake magnitude is written as m equals to log of intensity over default intensity I0. Is it okay?
Yeah.
So that is the given. We are given that the standard one to which we have to compare is 5 units. So 5 equals to log of I over I0. You can write it in the exponential form, which is 10 to the power of 5 is intensity over the default intensity, correct? So from here, you get the intensity as I0 into 10 to the power of 5. Perfect. Now, you are saying that the magnitude of the earthquake is 3 times as intense. So that I, which we are interested in finding, is 3 times I. I is already written as I0 10 to the power of 5. It has been rewritten. And now we can use this value and find the magnitude M. You see that?
Yeah.
I0 and I0 will cancel and we'll get our answer. Is that okay?
Mhm.
So that is how you should be doing it. You can write down this formula and I'll take up more questions based on the uh, magnitude of earthquakes, right?
Yeah. Okay.
Here's another one, similar kind, intensity of earthquake. Now, can you please read the question?
Yeah. How many times as intense as a standard earthquake is an earthquake measuring 3.1 on the Richter scale?
Right. So basically, I over I0, exactly what we did last time, follow the same steps. You see that?
Yeah.
Follow the same steps, get your result. So they are similar kind. Now, let's take up more examples based on sound intensity. This is another very important formula which will be used many times. So, can you please read this question?
The minimum intensity detectable by the human ear is 10 equals 10 to the power of negative 12 watts per square meter. The sound level corresponding to an intensity of
I was.
I watts per square meter is L equals 10 log I over I0. Find the sound level of a rock concert with intensity of 80 watts per square meter.
Correct. So, we are given the default, the minimum intensity detectable by human ear, I0, as 10 to the power of minus 12 watts per square meter. Right? That's the what you normally minimum. The sound level corresponding to intensity I watts per square meter is given by a formula which you should make a note of, which is L equals to loudness. L is the loudness here, equals to 10 times log of I over I0. Find the sound level, that is L, of a rock concert with intensity of 80. So just plug in 80 for I and I0 value is given to you as 10 to the power of minus 12, right?
Yeah.
And calculate your answer. So let's see the answer here. We'll go almost at the end of this video. So as I was saying, just plug in 80 for I and 10 to the power of minus 12 for I0 in this formula and calculate using calculator. You get your answer. Is that clear to you?
Yeah.
Next question, which is similar, loudness question. Can you please read the question again?
A sound is 1,000 times more intense than a sound you can just hear. What is the measure of its loudness in decibels?
Correct. So this time I0 value is not given to you. It was given in the last example. But normally in the test paper, it is always given, right? 10 to the power minus 12. So we are going to use that particular value and then find our answer. Is it okay? A sound is 1,000 times more intense as the sound you can hear. So, okay. So 1,000 times I0. You can hear I0. So the value was not given because I0 cancels. You see that?
Oh, okay.
So not given. So because I0, 1,000 times intense as the sound you can hear. So I0 is what you can hear, 1,000 times I0, they just cancel. So log of 1,000 is 3. So 3 times 10 is 30. So loudness is 30. Okay. Is that clear to you?
Yeah.
Next question, please. Here is your next question, which is again on intensity. Let's look into this. Yes. Can you please read the question?
How many more times intense is the sound of a normal conversation, which is 60 decibels, than a whisper, which is 30 decibels?
Correct. So 30 decibel is kind of a whisper, 60 is normal conversation. So we are already given the two values, their ratios can be found and you can solve the question, correct? So here is your solution. You have the formula L equals to 10 log I over I0, right? And you can compare the results as shown here. Okay, so loudness is given, which is 60 and 30. You could also do it like this. You have the formula loudness and loudness, correct?
Yeah.
Yeah. And when you come, you can actually find the ratio I over I0 of each and then divide one by the other, which has been done in the third step. Do you see that?
Mhm.
So first thing, from the logarithmic equation, write it as an exponential equation. So 60 equals to 10 log I over I0. 60 divided by 10 is 6. 10 to the power of 6 is the ratio of I and I0, correct?
Mhm.
And other side, it is ratio is 10 to the power of 3, correct? When you divide one ratio by the other, I0 cancel, the default, right? And you get the comparison which we are looking forward to, which is 10 to the power of 3 in this case, correct? So that is how you do intensity thing. Last example, which I'm going to share with you, is a practical application of welding. Can you please read the question?
Yes, a logarithmic scale is used for welding glasses, which protects the eyes from bright light. The shade number of welding glasses is given by the equation shade number equals 7 times negative log t over 3 plus 1, where t is a fraction of visible light that the glass transmits. When there is a solar eclipse, it is safe to look at it through number 14 welding glasses. What fraction of visible light is transmitted by number 14 welding glasses?
Correct. So shade number is given to you, which is number 14, correct? So you can plug that on the right hand side and find the value of t using your logarithmic laws, correct? Plus 1, you have to first deduct that, and the solution is given to you in this particular video, only 2.5 minutes video. So you see, in log, there are so many applications where we use logarithms, right? Difficult thing was to figure out the equation. Most of the time they are given to you, but you should make a note of all these equations for your reference and use them in the test when required. Otherwise, these are simple calculations, correct? So we'll end our class here today. We've done a lot of work. You can summarize our class learnings, okay?
Okay.
Okay, Chelsea, what did you learn today?
So today we learned about, we did at the start of the class a practice test. So we did finding exponential functions given log, finding logarithmic functions given exponential functions, graphing, transformations, And then we also talked about solving logarithmic equations. I think it was linear questions and then also quadratic ones. And then we also did application and word problems.
Good. So with that, I hope you have understood all the concepts. Feel free to share with me any doubts you have, and then we'll continue from there. Okay?
Thank you,
Great.
Peter.
Have a good day. Bye.